Hello, and welcome to this technical sound design video. My name is Parker, and I will be going through some of the technical sound design implementations I did in a game called Afloat. In this game, you fly around an atmospheric city catching fish for energy, and then depositing that energy into the building in the center of the map. The goal is just to make sure the city energy level doesn't get to zero. The first feature this game has is localization. The game dialogue is in English and Korean. Using Y's native localization, I built an exclusive sound bank just for dialogue. Then, I created a script to unload and load just the sound bank for dialogue, so that the music and sound effects could still play while this action was taking place. The second feature that was designed was a dynamic dialogue system. Using the city energy level and player energy level, we wanted the dialogue to react to any situation the player was in. Not only would the dialogue be different, but it would also try to hint to the player the next action they should take to win. Using Y switch containers and the two RTPCs of city energy level and player energy level, we were able to create this dynamic dialogue system. The first difficulty that we had in implementing this game was that the waterfall emitters didn't sound fluid as the player was flying down near them. The solution that was created was a spline. Doing a little research on vector math, we were able to implement a spline onto each waterfall and attach a single audio emitter on each spine. This allowed for a very fluid waterfall motion as the player went up and down a waterfall. Another difficulty that we had in this game was that the emitters were not feeling in the same space as the player. Now, since there is no Y's native Doppler plugin, we had to create our own. Using this equation on the screen, I created a C# script to apply a Doppler onto each emitter. We could tell if the player was coming and going from the emitter based on the distance that changed between the two on the last frame. This would allow us to know if it was coming or going, so if the pitch should go up or down. We then grabbed the player velocity and plugged it into the equation and applied this to each emitter in the game so that it really felt like the player was traveling through. That's everything for this video. Thanks for watching. Hope to see you again soon.